Hello friends, good evening, welcome to Chandu Biology Classes. So, let us continue our discussion on number system. This is part 3, this will be the final part of number system. So, what we are discussing, this is a series of classes that will continue for your APPSC and TGPSC JLDL exam. So, we are covering what topmost 40 important topics will be covered in upcoming days. Okay, we have started, and one request to all of you, those who have not watched polity sessions, please go through the playlist which I told you in the first class of this one. I mean day before yesterday or somewhat I told you where is the playlist, all these things. Please go through the polity playlist and then continue with this series. Okay, polity is completely covered, some topics are left that will be covered. Then after number system is done, we will go to modern history or something like that. So, important topics of modern history, geography, economy, all these things, and also current affairs, everything will be covered. Okay, even reasoning will be covered. So, that is one important information I would like to give you. Alright, and next we will start with number system, what we have done. Let me check whether it's the audio and everything is correct or not. Just a second. Alright. Good evening, Shamala. So, let us continue, friends. So, please pay attention to the classes. So, now let us start with number system. So, we were discussing which topic? We were discussing which topic? We were discussing number of digits topic. Number of digits. We were discussing number of digits topic, right? Now, when I talk about this, just a second. Just a second, I will be back. So, we were discussing number of digits topic. I will be back just a second, excuse me. All right, I hope I am audible. Sorry for the interruption. So, friends, we have to discuss what number of digits topic. So, when it comes to that, let me check the audio again. Yes, it is perfectly all right. Now, those who are on the chats, please respond whether I am audible or not. All right. So, we were discussing number of digits topic. Shamala, kindly respond. Are you able to listen to me? Are you able to hear me? Am I audible? Okay. So, first thing is number of digits topic. So, we have to discuss about what? We have to discuss about number of digits topic. In that I told the basics in the previous class. Let me revisit that and then we will solve the questions. Then we will go to very important topic, that is remainder theorem. There we will discuss elaborately about what are the things involved in remainder theorem. Okay, how the questions are being asked in the examination. Got it? Okay. All right. Now, now when you talk about number of digits, how the questions will come? Okay. Why we have to learn number of digits? Suppose you take in any book. Suppose you may take JLDL botany book or JLDL zoology book or whatever. You can see in the beginning there is something called menu. Okay, for each chapter they were given the page numbers, right? Suppose the book contains suppose it contains 1000 pages. Okay, so the number of digits required is what? We don't know. The book will be numbered from 1 up to page number 1000. Okay, it will be numbered from page number 1 to page number 1000, a large book. Okay, so up till 1 to 1000, how many digits are being used? From 1 to 1000, how many digits are being used? Digit means what? 1 is 1 digit. Here 1000 means how many digits are there? 1, 2, 3, 4. Like that, in between there are so many numbers. Correct? No? Each of the digits, if you add, how many digits are coming? That is the meaning of number of digits. So, how to find that? We will see here. How to find that? We will see here. Suppose, see here. Let me take a book here. This is a life science book. Alright, this is page number 1. Like that I have up to page number, so many page numbers are there. Now, if I go on counting this book, there are so many pages. So, in each of these books, see here, in each of these books, there is a number that is given. There is a number that is given. For example, here 23 is the number that is given. So, 23, how many digits are there? 1 plus 2, 2 digits are there. Like that, from page number 1 till page number, last page is here, I can see 748 is the page number. So, 748 means how many digits are there? 1 plus 2, 3 digits. Okay. So, page number 1 to 748, how many pages are there? Sorry, how many pages are there? 748 pages are there. But how many digits are being used? That is the concept we are learning here. I hope you understood now why we are learning this. Now, for this, the basics I told you in the previous class, let me revisit the basics. So, focus here. So, for single digits, definitely one thing you must understand, common sense is, we will not number a page as 0. There will no book that contains a page number as 0. It will start from 1. So, single digit means what? 0 to 9. In that 0 is removed. That means what? Single digit means we will consider from 1 to 9. So, 1 to 9, how many digits are there? Actually, it is 9 digits. It is not 10 digits. If it is 0 to 9, it is 10 digits. If it is 1 to 9, it is 9 digits. Okay, it is 9 digits. So, single digit means it is 9 into 1. So, how many digits are there? 9 digits. Okay, 9 digits. Okay, similarly, if I say double digit. If I say double digit, okay, double digit number starts from where? Double digit starts from 10. 10 up till where? It starts from 10 and ends at 99. Correct? No? Starts at 10 and ends at 99. So, how many double digit numbers are there? How to find out? 99 minus this 9, because this is the last number. 99 minus 9 gives me what? 90. Okay, 99 minus 9 gives me 90. Correct? No? But this is double digit means I have to multiply by 2. How much? I have to multiply by 2. If it is triple digit, multiply by 3. If it is 4 digit, multiply by 4. If it is 5 digit, multiply by 5. Like that, if it is double digit means multiply by 2. So, 2 into 90 is I am getting 180. I am getting what? 180. Now, triple digit. So, friends, focus here. Triple digit starts from where? 99 is double digit. So, the last number is what? 99. After that, the number comes is 100. That is what? Triple digit number. So, triple digit number is 100. Okay. So, 3 digit number goes up to where? It goes up to 999. Correct? No? It is going up to 999. Okay, 999. So, totally how many digits are there? To find out from 100 to 999, total how many digits are there? To find out that, just you can do 999 minus this 99. 999 minus this 99 gives me what? It gives me 900. It gives me 900. I should multiply this by what? I should multiply this by 3. Because why? This is triple digit number. I should multiply this by 3. So, if I multiply this by 3, what I am getting? 3 into 0, 3 9s are 27. This is the number I am getting. Okay, 180, this is 9 and 2700. Now, see here, friends, if I ask, so focus here, very important. What I am telling now is very important. If I ask you from 1 to 999, so from 1 to 999, how many digits are used? If I ask you from 1 to 999, how many digits are used? Or first, let me ask, 1 to 99. 1 to 99, how many digits are used means? So, from 1 to 9, how much are used? 9. Okay. So, from 1 to 9, it is 9. Okay. So, from 9 to or 10 to 99, it is how many digits are used? How many digits are used? 2 digit number, that is 90 into 2 is 180. Okay. So, from 10 to, it is from 1 to 99, how many digits are used means you have to add this. 180 plus 9 is 189. 180 plus 9 is 189. Similarly, if I ask a question from 1 to 999, suppose a book is having pages from 1 to 999, how many digits are being used? So, for that, how to find out? So, first is 1 to 9, how many are there? 9 digits. Next, 10 to 99, how many digits are there? 180. Okay, we found out just now. If I ask from 100 to, see here, from 100 to 999, how many digits are there? 2700. Total is what? 1 to 9, 10 to 99, 100 to 999. Total is what? 2700 plus 180 plus 9. So, total if you add it, it comes out to be 2889. Please remember this number. I want you to remember this number also. If they give 200 pages book or 100 pages book, so 1 to 100 is what? 1 to 100, how many digits are being used? 189. 1 to 100, 100 digits are not used. Don't assume like that. 1 to 100, 189 digits are used. If a book is containing 100 pages, how many digits are being used? 189 digits. If they are asking 1 to 999, how many digits are used? 2889. Okay, please remember like this. Please remember like this. Okay, this is the basic concept you have to understand. Now, based on this concept, if I say, okay, based on this concept, if I say there is a question that is asked in the examination, that is, question is how many digits are required, how many digits are required to number a book of 200 pages, number a book of 200 pages. This is the question. All right, this is the question. So they are asking, what is the question that they are asking? How many digits are required to number a book of 200 pages? That means what? A book is there, that book contains 200 pages. But to number those digits, how many digits are required? For each of the page, we have to number, give a number 1, 2, 3, 4, 11, 12, something like that, up till 200. So how many digits are required? How many digits are required? That is the question. So first of all, what we have to do is, see here friends, okay, already we know up to 100 how much it is? 189, we know that. But before that, let me write it in a basic way. So 1 to 9, it is a single digit number, it is 9 into 1, okay, so it will be 9. Okay, then next number is what? 10 to, what is it? 10 to 99. So 10 to 99, how many digits are there? 99 minus 9, it is 90, but it is double digits. 90 into 2 is 180. Okay, now which number is there? Which number is there now? 100. So 100 is 3 digit number. So 100 to which number? 100 to 200. Okay, it is 100 to 200. So it is, thank you sir. So it is 100 to 200. So how many digits are there? 100 to 200. Just a minute. How many digits are there? How to calculate? How to calculate how many digits are there? 100 to 200. So see here, 100 to 200 is there. So 200, how many digits are there? 100 to 200. So 200 minus 99 is what? 200 minus 99 is 101. 101. So 101 is how many digit number? This is how many digit number? This is a 3 digit number. So I'll write it as what? 101 into 3. So this becomes what friends? This becomes 303. This becomes 303. Now just I have to add all this. 180 plus 9 is 189. Okay, 189 plus this is what? Plus 303. So this gives me what? 9 plus 3 is 12. 8 plus 1 is 9. 3 plus 1 is 4. 499. So how many digits are required? 492 digits are required. Okay, 492 digits are required to number a book of 200 pages. Clear? Understood? Okay, those who are watching, for example, like Shamala Dharani, Manohar sir. Okay, I hope it is clear to all of you. So the answer is 499. Clear? So like this you have to write down, then it will be easy for you. Initially you please write down, then you can solve. Otherwise, with more practice you will be able to write the answer directly also. Clear? Because you know that 1 to 99 it is 189, or 1 to 100 you know that it is 189. Correct? No? Like that. 1 to 99 is 189. Okay, then 100 to 200, then you have to do it. 1 to 99 is 189. Clear friends? So let us see some more questions based on this. Okay, similar question, if they are asking for, okay, another question that is asked is 1300 pages. How many pages? 1300 pages. Same question, see here, same question, see here. They are asking how many digits are required, okay, how many digits are required to number a book having, I am writing in a short form the question, this is an examination question actually, to number a book having 1300 pages. 1300 pages. Okay, the book is having how many pages? 1300 pages. Okay, I hope you understood Muttudana. Okay, that's good. So it is 1300 pages. What is the procedure we have to follow? Okay, so I told you 1 to 999. I know that the number of digits how much? 2889. Otherwise I can follow the same procedure. If you don't know, suppose let us assume we don't know, what we should do? 1 to 9 is single digit, I should write it as 9 into 1, it is 9. I am writing fastly so that you understand. You already understood, I have told this basics now. Okay, so what about next number? 10 to 99. 10 to 99 is how many digits? It is 99 minus 9 is 90, 2 digit number, it is 2. So 90 into 2 is 180. Got it? Now 99, next number is what? 100. So 100 to which number I should write? 100 to only 3 digit number is 999. So 999 minus 99 is how much? 900 into 3, that is nothing but what? 2700. We got it as what? 2700. So how much we got? 1 to 999, how much we got? It is, I am taking from all total 1 to 999, we have to add all this, that is what? 2889. I have just added all this one, all the 3 I have added, I got it as 2889. Got it? Please share with your friends, it will be useful for them also. Okay, please follow the series, it will be highly useful. Everything that is required for GS paper 1, that is general paper, will be covered, okay, in the coming days, don't worry. Okay, 2818, all the important things, not some random things we are covering, all the important things that is repeatedly appearing in all the exams that we are covering, don't worry about that. So 1 to 999 is 2889. So remaining how many pages are left? So 1300 minus 999 is how much? 1300 minus 999 is how much? It is nothing but 99. Okay, 13 minus 9 is how much? 13 minus 9 is how much, friends? It is 13 minus 9 is how much? So 13 minus 9 is, it is 499. Okay, so the remaining numbers are what? I have to count from 1000 to 1300. 1000 to 1300. So I have to count these pages. Okay, 1000 to 1300. So 1300 minus 999, how much I am getting? I am getting it as 499. 499. But here I have multiplied by 3. Okay, but here I should multiply by what? I am getting it as what? I am getting it as actually 1300 minus 999. So this will be what? Actually this subtraction I have done it wrong, sorry. So this becomes what? Observe very carefully. 1300 minus 999. So 10 minus 9 is 1. Okay, 9 minus 9 is 0. Okay, 12 minus 9 is how much? Okay, 12 minus 9 is how much? 300. Okay, this is what? 301. I got it as what? 301. But this is how many digits number? This is 4 digit number. 1000 to 1300 is how much? 4 digit number. So I have to multiply this by 4. What I will get? If I multiply this by 4, I am getting it as 4 1s are 4, 4 0s are 0, 4 3s are 12. Now this and this, if I add it, I will get my answer. So I have to add this, that is what? 2889 plus 1204. Okay, so 9 plus 4 is 13, 8 plus 1 is 9. Okay, 8 plus 2 is 10. Okay, 2 plus 1 is 3, 3 plus 1 is 4. So the answer is what? The answer is 4093. The answer is what? 4093 is the correct answer to this question. Okay, this is how you have to solve this question. Clear, friends? So the answer is 4093. How many digits are required? 4093 digits. Okay, 4093 digits are required. This is one type of question they will ask. Another type of question that they will ask is, they will only give the number of digits and they will ask how many pages the book has. Okay, next type of question is, they will give, you can observe this. I hope the solution is clear to you. If you want, you can take a screenshot or write it down. Okay, you can pass and write it down later. Okay, so next question is, suppose a book has 3089 digits. Okay, how many pages are there in the book? This is UPSC CSAT question. I am getting you very important and very good questions that has been asked in various examination. UPSC CSAT 2020. This is okay. UPSC CSAT 2020 question. So this is reverse. So they are only giving the number of digits. Okay, options are they have given the options also. That is, A is 1040, B is 1048, C is 1049, and D is 1050. Okay, and those who have not watched number system part 1 and part 2, please do watch it after the class. Okay, please do watch it. You will learn a lot of things. We have done classification of numbers, divisibility rule, and also number of zeros, and also unit digit. Okay, please watch that part 1 and part 2 also, and please do share with your friends. Now when I talk about a book has 3089 digits, that means this is ulta, that is they are asking reverse. Earlier they were only giving the pages. Okay, they were giving the pages and they are asking for digits. Digits is how much they were asking. Now they are giving the digits, and they are asking for pages. Okay, they are asking for pages. Okay, a book is numbered with digits, 3089 digits are used in that book, but how many pages that the book has? That is what they are asking. So for that also same procedure, nothing to worry. So what is that we have? So directly I can write 1 to 999, that is 1 to 999. How many pages we have? 2889. How I am telling? See here, I told you in the concept, while telling the concept I told you. See here, while telling the concept I told you, that is 1 to, see here, 1 to 999. How many pages are there? There are 2889. That is what I am using. So this becomes what? This becomes equal to, see here, this becomes equal to 2889. Now what about remaining pages? How many digits the book has? The book is having how many digits? They are telling 3899. So remaining pages are what? It starts from 1000. It starts from 1000 and it is ending at 3089. It is ending at what? 3089. Okay. So if I do 3089 minus 999, 3089 minus 999, how much I am getting? So see here, 3089 minus 999 is nothing but what? 9 minus 9 is 0. Okay. 18 minus 9 is 9 itself. 18 minus 9 is 9 itself. Okay. 18 minus 9 is 9 itself. 29 minus 9 is 20. 29 minus 9 is 20. So the number of pages that I am getting is here, the remaining number of pages that I am getting is how much? That is nothing but how much? 1 to 999 is 2889 digits. Okay. The pages from, that is digit number 1000 to 3089. How many? The difference is how much? So the difference is 9 minus 9 is 0. 18 minus 9 is 9. Okay. 18 minus 9 is 9. So 29 minus 9 is 20. So this is how much the difference is coming out to be 2090. But here, how many? This is how many digit number? These are 4 digit number. So if you are getting 4 digit number, if you multiply, you will get the number of digits. But I want the number of pages. If I want the number of pages, instead of multiplying by 4, what I should do? I should divide by 4. Okay, instead of multiplying by 4, I have to divide by 4 because I want the number of pages, not the digits. So I got the number of digits like this. I have to divide by 4. Correct? No, I have to divide by 4. So what I should do here? 4 5s are 20. Okay, 4 5s are, let me have a look at it. So this becomes what? This becomes, what is, how much is left? This becomes what? 3089. That is, this is 2090. Remaining is 2090. So this is what? 4 1s are 4. Okay, 4 5s are 20. Okay, 4 5s are 20. This is what? 4 5s are 20. 4 2s are 8. Okay, 4 2s are 8. Okay, 4 2s are 8. Okay, remaining is what? 522. 522. So what I should do is here, simply what I should do is here, this is turning out to be how much? 1 to 999. Remaining pages are how much? They are telling 3089 digits. 3089 digits. Actually, what I should do here is, see here, this is not required actually. See here, they are telling 3089. Correct? No? 3089. So after 999, what is the digit that I will get? 1000. So this is how many digit number? 4 digit number. This is 4 digit number. This is 4 digit number. So no need to do this. This will become more complex, not required. So what I can do is, this is 4 digit number. Observe here, 3089 is there, 2889 is there. So what I should do? I should do 3089 minus 2889. I should subtract. So how many digits are there? That I should divide by 4 because they are 4 digits number. So 9 minus 9 is 0. 8 minus 8 is 0. So what is this? 10 minus 8 is 2. Okay, this will be 0. So this is 200. So I will get what? 200. This 200. These are all what? These are all 4 digit number. So 200 4 digit numbers I will get, means I have to divide by 4. This is 4 1s are, 4 5s are. So 50. So the number of pages that is remaining is 50. So 1 to 999 is 2889. So for remaining digits there are 50 pages. So how many pages are there? So 1 to 999 plus 50 pages. That is nothing but what? 999 plus 50 is what? 999 plus 50 is nothing but 1049. Okay. 1000 plus 50 is what? 1050. But actually it is not 1000. It is 1 less than 1000. So it will become 1049. The answer is 1049. That is option C. That is option C. Is it clear, friends? If you have understood, please give a thumbs up. Okay. Please give a thumbs up if you have understood. Okay. Here it is a reverse question that they are asking. Here what they are asking? It is a reverse question that they are asking. Here they are only giving the digits. We have to find the number of pages. So 1 to 999, it is 2889. Okay. Remaining how many pages are there? 3089 is the number of digits. So if I find the difference between the two, I am getting it as 200. So these digits are what? 4 digit number. So 4 digit number means I have to divide this difference by 4. If I divide the difference by 4, I am getting it as 50. That 50 I have to add to the number of pages. Till now I have used how many pages? 999 plus 50 pages is what? 1049 pages. So the book has how many pages? 1049. Okay. Those who understood, please give a thumbs up. Okay. Those who understood, please give a thumbs up. Okay. So let us move to the next type of questions. You understood? Let us move to the next type of question. That is next type of concept. That is remainder theorem. That is remainder theorem. I hope you have understood. Let us move to the next type of question. That is based on remainder theorem. That is based on remainder theorem. I hope you have understood. Okay. No response. Let us see. Please wake up and listen. This is what? Remainder theorem. Very important concept. Questions are coming directly from here. So remainder theorem. Focus here. See friends, if I write 22 by 3, if I write 22 by 3, what I am getting? So I am focusing only on the remainder. So this will be 3 ones are 3 sevens are. Okay, what is the remainder that is left? That is 1. So how I am writing this? I am writing this as 21 plus 1 divided by 3. So 3 ones are 3 sevens are. Okay, remainder is what? 1. Similarly, if I write 80 by 7, if I write 80 by 7, okay, if I write 80 by 7, what I am getting? 7 ones are, okay, 7 11s are. 7 11s are is what? 77. Remainder is what? Remainder is coming out to be 3. This how am I writing? I can write this as what? I can write this as 77 plus 3 divided by 7. Okay, 7 ones are 7 11s are. Remainder is what? This is 3 is the remainder. Correct? No, this 3 is the remainder that I am getting. Now, what I should do is, now this is what we are getting? Positive remainder. What we are getting? This is positive remainder. These are all what? These are all positive remainder. Okay. Now, what we got here? Positive remainder. Positive remainder. Next, I will talk about negative remainder. Negative remainder. Negative remainder. Okay. Positive remainder. So, if I divide 22 by 3, what I am getting remainder is 22 by 3. What I am getting remainder is 1. This is positive remainder. If I am dividing 80 by 7, okay, what I am getting remainder is 3. This is positive remainder. So, what I can do here is, if I want to get a negative remainder, okay, if I want to get a negative remainder, what I can do is, see here friends, what I can do is, see here, what I can do is, see here, one thing you have to understand, okay, when I divide something, this 80 by 7, okay, here this number, denominator, this number is called what? Divisor. This number is called what? Divisor. So, when I talk about divisor, this divisor actually is equal to what? You have to understand that positive remainder I will write it as P, negative remainder I will write it as N. So, this divisor is equal to positive remainder plus negative remainder. Okay, this divisor is equal to positive remainder plus negative remainder. Okay, this is the concept you have to understand, very important. This is the my star step you have to understand. Let me put it in some another color so that you understand. So, this is the thing you have to understand, very important. So, divisor is equal to what? Positive remainder plus negative remainder. Divisor is what? 7. Here divisor is what? 3. So, divisor is equal to what? Positive remainder plus negative remainder. Positive remainder we got it as 1 here. Positive remainder we got it as 3 here. What will we get with the negative remainder? How to find out? So, we can find it out very easily. Okay. In this case, what is the divisor? Divisor is 3. Divisor is equal to positive remainder plus negative remainder. Okay. 3 is equal to positive remainder is what? 1. So, plus n. So, negative remainder is equal to what? 3 minus 1, that is equal to 2. So, negative remainder is equal to 2 in this case. Got it? Negative remainder is equal to 2 in this case. What about this one? See here, divisor is how much? 7. Divisor is how much? 7. So, 7 is equal to what? Positive remainder plus negative remainder. So, 7 is equal to positive is how much? Positive is how much? Here we are, what we are getting? Positive remainder. Positive is 3. Okay. What about negative remainder? We don't know. Let us write it as n. So, n is equal to what? 7 minus 3. Okay, 7 minus 3, that is equal to what? 7 minus 3 is equal to 4. So, negative remainder is what, friends? Negative remainder is 4. Okay, negative remainder is equal to 4. Like this we have to solve the questions. Okay, suppose suppose I give one more question. Suppose I give one more question. Okay, suppose I give one more question. 33 by 4. So, here if I ask a negative remainder, find the negative remainder of this. First I will find the positive remainder. Positive remainder of this is 1. So what about the positive remainder? I got it as 1. What about the negative remainder? Negative remainder is divisor minus 1. Divisor minus 1 is, it is nothing but 3. That is 4 minus 1, that is nothing but 3. Like this you have to find out. Sometimes you may get positive remainder also, negative remainder also. They will ask what is the divisor. Sometimes they will give divisor also, negative remainder also. They may ask what is the positive remainder. For everything, this box, whatever is in the box will be useful for you. Clear, friends? Now based on the remainder theorem, there is one important thing that is called Fermat's theorem. That is called Fermat's theorem, friends. Okay, but before going to Fermat's theorem, I want to teach you law of exponents, which you must be already knowing, but I would like to explain again. Law of exponents. Law of exponents. Law of exponents. So law of exponents says what? If a to the power of m into a to the power of n is given, okay, that is a to the power of m into a to the power of n, that is base is same, that is a, then it can be written as a to the power of m plus n. Alright, next a to the power of m divided by a to the power of n is given, that time we can write it as what? A to the power of m minus n. Okay, then another thing is a to the power of m to the power of n is given, means a to the power of m into n. A to the power of m into n, or I can write it as a to the power of mn. M into n means nothing but mn. Clear? These important thing, these are the laws of exponents which you have to remember. Suppose I give a question like this. Suppose the question is given like this. 2 to the power of 32 is given. 2 to the power of 32 is given means I can write it as what? I can write it as actually 2 to the power of 2 into 16. That is what? This is the formula I am using. Or I can write it as what? 2 to the power of 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 4 into 4. Okay, because 4 into 4 is 16. Okay, 4 into 4 is 16. Actually, this is not the thing. Let us write it like this. 2 to the power of 4 into 2 to the power of 4 into 8. 2 to the power of 4 into 8. Or I can write it as what? 2 to the power of 8 into 4. Further, if I write it like this, we can split it. Like this, we can split it. Or if I have something like, see here another example. If I have something like 216 to the power of 216 to the power of 2, I can write this as what? 216. I can write it as 6 cube. 6 cube is 216. 6 cube to the power of 2, or I can write it as what? 6 to the power of 3 into 2 is 6. 3 into 2 is 6. These are the laws of exponents which you have to remember. Now let me go to the Fermat's theorem directly. Okay. So Fermat's theorem. Fermat's theorem. This is also actually Fermat. This is a continuation of remainder theorem only. A person named Fermat gave an important formula that is important for us to find the values. Fermat's theorem. Okay. This is applicable. When it is applicable? Applicable when denominator, that is what? That is nothing but divisor. Denominator or divisor is a prime number. Okay, is a prime number. It is applicable when denominator or divisor is a prime number. It is applicable when denominator or divisor is a prime number. It is applicable when denominator or divisor is a prime number, then only this is applicable. So what does the Fermat's theorem say? So what does the Fermat's theorem say? Let us see that. Okay, what does the Fermat's theorem say? Let us see that. Okay, so if you take any number, okay, suppose prime number, this is the p, that is the p is nothing but divisor or denominator which is a prime number. If numerator we have a, okay, it is of the form power is a to the power of p minus 1. Okay, power is a to the power of p minus 1. So the answer will be equal to 1. So the answer will be equal to 1. So okay, power is a to the power of p minus 1. So the answer is equal to 1. Okay, the answer is equal to 1. The answer is equal to 1. So a to the power of p minus 1 by p is equal to 1, where p is what? P is a prime number. Where p is what? P is a prime number. Okay, where p is what? P is a prime number. Suppose if I take some examples, see here, if I take some examples, okay, if I take some examples, if they are given 15 to the power of 16 divided by 17, what is the value of this? They are asking. 15 to the power of 16 divided by 17. I am not at all bothered about what is 15. Okay, I am not at all bothered about numerator, that is 15. Okay, I am only focused on this power and also denominator. Denominator 17 is a prime number. Whenever you get a prime number as denominator, think whether you can apply Fermat's theorem. This is what? Prime number. Correct? No. So this can 15 can be written as what? 15 to the power of, see, observe here. This can be written as what, friends? This can be written as, see here, this can be written as 15 to the power of 16 can be written as what? 17 minus 1 divided by 17. This of which form? A to the power of p minus 1 by p. This is nothing but equal to 1. So this definitely, this value will also be equal to what? This will be equal to 1. The answer is equal to 1. Clear? The answer is equal to 1. 15 to the power of 16 by 17. 17 is a prime number. 16 can be written as what? 17 minus 1, or sorry, 17 minus 1. Correct. 16 can be written as what? 17 minus 1. So that value is equal to what? That value is equal to 1. That value, the entire value becomes equal to 1. Got it? The entire value becomes equal to 1. Now, if I write what is this? This one is nothing but what? This is nothing but the remainder. This is not the quotient. This is nothing but the remainder. This is nothing but the remainder. Got it? This is nothing but the remainder. Okay. Next, one more question of this type. Suppose I write, see here, 17 to the power of 23 by 23. 17 to the power of 23 by 23. Can I apply Fermat's theorem here? Definitely, denominator is prime number. Okay, this is 23. So 23 can we write it as, this is what? We have to write it in the form of a to the power of p minus 1 by p. But here this is of which form? This is of which form? This is of a to the power of p by p. Can we apply Fermat's theorem here directly? No, directly we cannot apply. So what we can do here? We can modify this. So this one, 17 to the power of 23 by 23 can be written as what? We can split it into two ways. This is 17 to the power of 22 into 17. So this is what? 17 to the a to the power of m into a to the power of n is a to the power of m plus 1. This is 17 to the power of 22. This is 17 to the power of n divided by 23. I can make it. Now focus on only this thing. Focus on only this thing. Now this will become what? 17 to the power of, this is what? 23 minus 1 by 17 by not 17. This will be actually 23. Okay, this will be 23. This will be 23 into another 17 is there. We will leave it. Okay, this will be 17 by 23. This is for this. If you focus, see here. This is what? Fermat's theorem. If I apply, this is what? A to the power of p minus 1. P is what? 23. This 22 is what? 23 minus 1 by 23. This entire thing will become equal to 1. So this is what? 17 by 23. 17 by 23. 17 by 23. 17 by 23. The remainder is what? The remainder is 17. See, whenever you get any value, suppose I write 3 by 5. 3 by 5. If numerator is less than the denominator, what is the remainder? Remainder is numerator itself. Okay. Okay. If numerator is less than the denominator, then remainder is equal to what? Remainder is equal to numerator itself. Remainder is equal to numerator itself. Okay. Remainder is equal to what? Numerator itself. But in the options they may given 2 as the remainder. That time that is also correct. Why? Because divisor is equal to positive remainder plus negative remainder. Okay. Divisor is what? 5 here. Positive remainder is, see here, divisor is 5 here. Positive remainder is what? 3 plus n. So this implies what? This implies n is equal to this implies n is equal to 5 minus 3, that is equal to 2. So most important thing which you have to remember here is this box. When numerator is less than denominator, remainder will be equal to numerator. That is one important thing you have to remember, friends. That is one important thing we have to remember. Okay. Let us see some questions based on Fermat's theorem. So first question that is given is, see here, first question that is given is, see here, A. First question that is given is A is equal to, that is what? Find the remainder. Find remainder. This is the question that is asked in the examination. Find remainder. So please make note of it. So find remainder when 38 to the power of 102 divided by 103. Second question is, see here, they have given 64 to the power of 30 divided by 31. Okay, 64 to the power of 30 divided by 31. Okay. Now another thing that they have given is, C is 187 to the power of 82 divided by 83. Okay, these are the questions that they have given. Okay, this is the question that they have given. Now, how to solve this question? See here. So, 38 to the power of 102 divided by 103. So, this can be written as what, friends? 38, 102 can be written as 103 minus 1 by 103. 103 is a prime number. So, the answer is what? 1. Remainder is 1, because this is of which form? A to the power of p minus 1 by p. This answer is 1. Similarly, this can be written as what? 64 to the power of 30. 30 can be written as what? 31 minus 1 divided by 31. The answer is 1. The answer is 1. Very simple, clear. Okay. Similarly, 187 to the power of 82. 82 can be written as what, friends? 83 minus 1. Correct. So, this will become 83 minus 1 divided by 83. This is of which form? A to the power of p minus 1, that is p is 83 by p. P is 83, that is equal to, answer is equal to 1. So, we will get the answer is equal to 1. Got it, friends? This is how we can solve this question. This is how we can solve this question, friends. I hope it is clear. I hope it is clear. I hope it is clear. Let us move to the next type of questions that is there. Okay. Now, we understood when the denominator, remainder theorem, we understood when the denominator is prime number, we applied Fermat's theorem. But suppose one more question, let me take one more question. 3 to the power of 21 by 5. Okay, this is the question that they have given. 3 to the power of 21 by 5. Find the remainder they are telling. Okay, for this, how I can write 3 to the power of 21? I can write it as what? 3 to the power of 1 into 3 to the power of 20 divided by 5. Correct? No. Now, this 20 can be written as what? This 20 can be written as, first let me write down this 3 to the power of 1. This 20 can be written as what? 20 can be written as 5 into 4. Okay, 5 to the power of 4. 5 4s are 20. Okay, this will be 5. Okay, this becomes what? This becomes what first? See here, this will become 3 into 3 by 5. 3 by 5 will be separate. Okay, this if I write it, this will be 3 to the power of 5 into what I will write it? 4 can be written as what? 5 minus 1 by 5. So, this is nothing but what? Fermat's theorem. So, this entire thing will become equal to 1. So, we will be left with 3 by 5. So, the remainder is what? Numerator is less than the denominator. The remainder is 3. Okay, the remainder is 3. The remainder is 3 or negative remainder is 2. Got it, friends? This is how you can solve this question. Now, another type is we understood when the denominator is prime number, we applied Fermat's theorem. But when the denominator is not a prime number. Denominator is not a prime number. Okay, that time suppose a by b is there, b is not prime number, not prime number. Okay, prime number. That time we have to bring it to a form where we can apply b plus or minus 1 to the power of n by b. This will be equal to 1. This will be equal to 1. Okay, b plus or minus 1 is equal to b. This will be equal to 1. So, for this there are two conditions. One is what? If it is b plus 1 by b to the power of n, the answer is 1. The answer is 1 if it is plus 1. Or if you have b minus 1 to the power of n by b, okay, if it is odd, or b minus 1 to the power of n, okay, by b if n is even. If n is even. Okay, so let us take some examples. So, if n is odd, if n is even. Okay, 10 to the power of 82 by 9. Okay, 10 to the power of 82 by 9. Okay, so if n is odd, this is minus 1. Okay, if it is b plus 1 to the power of n, plus means it is always 1. If it is minus, if n is odd, it is minus 1. If n is b minus 1, if n is even, it is plus 1. So, the question that we have is 10 to the power of 82 by 9. Okay, if I take examples here, 10 to the power of 82 by 9. 10 to the power of 82 by 9. So, here b is what? 9. B is what? 9. So, I can write it as what, friends? I can write it as, this can be written as what? B plus 1 to the power of n by b. This will become equal to 1. How? See here, 10 to the power of 82 by 9 can be written as what? Can be written as what? 9 plus 1. 10 can be written as 9 plus 1 to the power of 82 by 9. So, if it is plus, it does not matter for us, whatever is the power. So, this will become equal to 1. Whether this is odd or even does not matter. If it is plus. Another question where minus is there, let me take it. So, 15 to the power of 20. 15 to the power of 20. Okay, 15 to the power of 20 by 16. By 16. 16 is what? It is not a prime number. 15 to the power of 20. So, this I can write it as what? 15 can be written as 16 minus 1 to the power of 20 by 16. Okay, this is b minus 1 to the power of n by b. Okay, but here n is what? N is even. N is even means the answer will be equal to plus 1. Suppose I take 25 to the power of 20. Okay, 25 to the power of 20, or instead of power of 20, let me take it as 25 to the power of 25. 25 to the power of 25 by 26. 25 to the power of 25 by 26. 26 is not a prime number. So, this 25 can be written as what, friends? 26 minus 1 by 26 to the power of 25. Here b minus 1 by b, n is what? N is odd. This is odd. So, the remainder will be equal to what? Minus 1. The remainder will be equal to what? This is equal to minus 1. So, I hope it is clear. This is how you can solve this question, friends. This is how you can solve these questions. So, that is all about remainder theorem. HCF LCM I will do when we do some other classes of quantitative aptitude, where we will do percentage, ratio and proportion, highly important topics, profit and loss, all these things, and data interpretation, that we will try to cover in general aptitude class. Got it? When it comes to JLDL, APPSC and also for TGPSC exams. Got it, friends? So, this is about number system. We have covered classification of numbers, divisibility rule, number of zeros, unit digit, number of digits, and also what is it we covered? Remainder theorem. Under that we covered Fermat's theorem, when the denominator is prime, and when the denominator is not prime, we use this thing, b plus 1 by b plus 1 to the power of n by b will be equal to 1, will always be equal to 1, if it is b plus 1. If it is b minus 1 to the power of n by b, it will be equal to 1 if it is n is even. If n is odd, it will be equal to minus 1. That is it, friends. I hope it is clear. I will wind up the class now. Thank you so much. Please stay tuned to Chandu Biology Classes for more such quality content. Okay. So, please prepare very well and please revise the classes and make notes. Okay. Thank you. Take care.